When you picture a science lab, what do you see? Probably a bunch of beakers, flasks, and test tubes, right? They seem so simple, so familiar. But you know what? That simplicity is actually a brilliant disguise. Today, we're going to pull back the curtain and show you how these humble glass containers are really masterclasses in purpose-driven engineering. And we'll start with a question that might mess with your head a little bit.
What if I told you that those measurement lines on the side of a standard beaker are basically a lie? Yeah, I know, it sounds crazy, but asking that question gets us right to the heart of what we're exploring today, the critical and, let's be honest, often misunderstood world of laboratory glassware.
Because hidden in the shapes, the slopes, and even the thickness of all that glass are some incredible design secrets. Secrets that, frankly, make modern science possible. So let's start decoding them.
Okay, so here's the #1 rule you have to understand. In the lab, shape dictates function. Every single curve, every spout, every narrow little neck you see is there for a reason. This isn't about looking cool. It's about engineering a tool for a very, very specific job. And if you pick the wrong one, well, your entire experiment could be a bust before you've even really started.
This brings us to probably the single most important concept we're going to cover. I call it the precision divide. It's this fundamental difference between the everyday workhorses of the lab and the high-stakes instruments of pure accuracy.
And this slide, right here, just lays it all out perfectly. Over on the left, you've got the good old beaker. Its wide mouth is awesome for pouring and mixing stuff. But those lines on the side, they're just ballpark figures, estimates. Now, look to the right. That's a volumetric flask. It is designed for one job and one job only, to hold one single, super accurate volume. And that long skinny neck, that's the secret sauce.
So why does a narrow neck mean high accuracy? Well, it all comes down to what you could call the bucket versus straw principle. Think about it. If you add a little bit of water to a wide bucket, the water level barely seems to move, right? But if you add that exact same amount to a thin drinking straw, the level shoots way up. That's what volumetric glassware does. It uses that straw principle to make tiny, tiny differences in volume super obvious and easy to measure accurately. It's just simple, brilliant design.
But look, having the right tool is only half the battle. You have to know how to use it. When you put water in a narrow tube, the surface forms this little curve called a meniscus. And for a truly precise measurement, your eye has to be perfectly level with the very bottom of that curve. If you look down from above or up from below, you're going to get the wrong reading. So it's not just the tool, the technique has to be perfect too.
All right, so I think we've got a good handle on precision with liquids. Let's broaden our tour a bit and check out some of the other essential and cleverly designed tools you'll find sitting on a lab bench.
When you're dealing with solids, the solutions are often just beautifully simple. I mean, the mortar and pestle for grinding things up, that design is literally thousands of years old. A simple spatula is just perfect for moving powders around. And a watch glass, it's a total multi-tool. You can use it for holding stuff, covering a beaker, or letting liquid evaporate. It just goes to show you sometimes the most basic design is exactly the right one for the job.
Now, what about heating things up? You can't just stick a beaker right over a hot flame. The thermal shock would crack the glass in a second. No, you need a system. The tripod gives you a stable platform, but the real unsung hero here is the wire gauze. It's that little mesh square that sits between the flame and the glass. It spreads the heat out, diffusing it evenly across the bottom so nothing gets too hot too fast. It's a simple little thing that prevents a total disaster.
Okay, so we've seen the individual instruments. Now let's watch them all come together as a team in a real-world procedure called a titration. This is where precision is absolutely everything and where all that design theory we've been talking about gets put to the test.
In a procedure like this, there's a kind of mantra that chemists have. Slow is smooth and smooth is fast. What that means is, if you rush, you're going to make mistakes and have to start all over again. This whole thing is a game of patience, control, and using exactly the right tool at exactly the right time.
So our scientist, let's call him Alex, he starts with a volumetric pipette. Now, this is in for about a spoonful. This thing is designed to pick up and transfer one single hyper-accurate volume of his sample. The success of the entire experiment literally depends on this first measurement being absolutely perfect.
Next up, that perfect sample goes into an Erlenmeyer flask. Now, why not just use a beaker? Because Alex is going to need to constantly swirl this solution, and that conical sloped shoulder shape is a genius design that lets him mix everything vigorously without a single drop splashing out. If he lost even one drop, the whole result would be wrong. Okay, time for the other half of the reaction. Alex grabs a beaker, the right tool for just holding and pouring, to fill up the most important instrument on the bench right now, the burette. He's probably hearing his old chemistry instructor in his head. A beaker is for holding, a burette is for measuring. The burette is this long, thin tube with super precise markings and a little valve at the bottom, called a stopcock, that lets you add liquid 1 drop at a time.
So, with his hand on that stopcock, Alex begins. He adds the titrin from the burette into the flask that he's constantly swirling. He's watching, just waiting for the chemical reaction to finish, which is going to be signaled by a sudden color change. He slows the flow, now he's adding it 1 single drop at a time until, bam! 1 final drop transforms the entire solution from clear to pink. That's the endpoint. Nailed it.
So let's just recap that. Every single tool had a critical, non-negotiable job. The pipette made sure the starting sample was dead-on accurate. The flask let him mix safely without losing any of it. The burette delivered a precise, measured volume. And, of course, the safety goggles protected the most important instrument in the entire room, the scientist himself. And that whole titration story just perfectly demonstrates our central theme today. The quality of the science you're doing is completely inseparable from the quality and the design of the tools you use to do it.
So what are the big takeaways here? If you remember anything, remember this. 1. Shape is function. Every curve has a purpose. 2. You have to understand the precision divide, the huge difference between tools for estimating and tools for measuring accurately. And 3. Real success in the lab comes from knowing exactly which tool to grab for which task.
So, the next time you see a piece of lab glass, hopefully you'll see it a little differently. You'll know the secrets it's holding. And that really just leaves me with one last question for you. What other simple, everyday objects in your life are hiding their own secret genius?